Okay, in this video, let's combine everything that we have learned so far and see how logistic regression can be used to classify images. But before we really get into it, let's talk about one last topic, which is addition of two lines. So let's say we have this line and we want to add it to that line. Then how do we do that? So let's represent those two lines together. And when we add the two lines, we are getting the resulting line as the representation of one line with respect to the other line. And let me repeat that. When we add two lines, the result is nothing but one line represented with respect to the other line. And which line we represent with respect to which line is does not matter, but just keep in mind that when we sum any two lines, we are representing one with respect to other. So let's see how that works. If you want to represent this line with respect to this line, what that means is that that reference line now becomes our new x-axis. So since the original line is slightly below x-axis on the left and above x-axis on the right, if this becomes our new x-axis, then the resulting line will be slightly below that new line on the left and slightly above the new line on the right. And that's exactly how the resulting line looks, which is slightly below the original line here and slightly above the original line here. So you can see that line here is our resulting line. Now, if you want to imagine that as the other way around, where we are using this line and finding the representation with respect to this line, then we'll also come up with the same resulting sum. You can think of it on your own, but let's move on from here and let's see how we can utilize this information to understand our logistic regression. So finally, we are at the topic which we have been waiting for a long time, which is identifying whether there's a mask in an image or not. Basically what that means is we want to classify the image as either 0 or 1, but that's what logistic regression can do for us right now. And that will help us understand how the entire system works. And for simplicity, let's assume that this is our grayscale image or a black and white image. It does not have any color, it's shades of gray. And for also another simplicity, let's assume that our image is just 1 pixel by 1 pixel. So it's just 1 pixel and we want to classify that pixel and see whether there is a mask or not in that pixel. Well, that is actually meaningless in a way, but that will help us understand the concept, and then we can see how to extrapolate that to actual picture, which is 1000 pixels by 1000 pixels. So since this is 1 pixel by 1 pixel, it is actually just one number. So we can represent this entire image with just one number, which is x. And since it's one number, our machine is going to conveniently use that x on our x-axis and try to find y, which is going to be between 0 and 1. And depending on what the value of y is, it's going to say whether there's a mask or not. So if the value of y is closer to 1, which is going to be beyond this point on the right, it's going to be saying that there's a mask. If the value of y is less than this point on the left, then it's going to be saying that there is no mask. And just for you to remember, this point is nothing but y equal to half. And for any x which is greater than this, it's going to say that there is a mask. And for any x less than this, it's going to say that there's no mask. Now keep in mind that this, on the extreme left, this point where x is 0 is completely black pixel. There's nothing in it. And this point is extremely right here. Maximum white is nothing but a fully white pixel, which we can call x equal to 1. So the range of this here is 0 to 1, and the range of this here is also 0 to 1. Also, don't forget that this bent line, the sigmoid, is coming from our straight line. So let's never forget that. So just to recap what I just told you, our single pixel image is actually resulting in one line, and that one line is finally bent to give the sigmoid, which gives us the value of whether there is a mask or not in that pixel. Now let's take a little more complex image which has got 2 pixels. So 2 pixels by 1 pixel. It's not a very complex image, but slightly more complex than the previous one. So there's going to be one straight line associated with the left pixel and one straight line associated with the right pixel. And we are going to add these 2 lines like how we saw some time ago, and the sigmoid is going to act on the resulting line, and that is going to give us whether there is a mask in this 2 pixel image or not. Now similarly, if we have 4 pixels, which is 2 cross 2, so we have basically 4 pixels, we are going to have 4 straight lines, one associated with each pixel, and we are going to add those 4 straight lines, and the sigmoid is going to act on the resulting straight line, which is the sum of these 4 straight lines, and that sigmoid is finally going to give us the result of whether there is a mask or not. When you add these 4 straight lines, you can add them in any order. So this plus this plus this plus this, or this plus this, and then this plus this. It doesn't really matter. But in a nutshell, when we have an image which is 1000 pixels by 1000 pixels, we'll have 1000 straight lines for 1000 rows and 1000 for 1000 columns. So we basically have 1000 into 1000 straight lines, that is 10 to the power 6, 1 million straight lines. And what the machine does is it sums up all of those straight lines and comes up with one straight line, which is the sum of all the straight lines, and sigmoid acts on that resulting straight line. And finally, after the sigmoid, we get whether there's a mask or no mask in that image. Well, that is all. That gives you all the information needed to write your own script in any language to determine how to use logistic regression to find a mask or no mask in an image, and also to actually train the entire logistic regression process, because you also know how to calculate the loss. You also know how data is represented and how backpropagation works. When, if you remember, we saw that bowl-shaped curve. That concept is called backpropagation. So if you go each step at a time, you will be able to write your own logistic regression. And in fact, you can actually see the Coursera course by Andrew Ng and see the assignment, the very first assignment for that. That might help you in applying the concepts that we have learned so far. Cool, thanks a lot for watching. In the next video, we're going to look at more complex networks, which is going to have more than one sigmoid, and we'll see how that works in the future.